In this video, I'm going to be going over scenario 2, which is asking the question, what causes the balloon to levitate that plastic ring up in the air? All right. So our objects in this case are going to be, to start with, are going to be the fur and the balloon. The fur is an insulator. Right? It has 10 atoms, so 10 protons I have, and it's also neutral, so I have the exact same amount of protons and electrons in this model. It's going to be the exact same thing with the balloon. It's an insulator, 10 atoms, it's neutral, so same amount of electrons and protons. All right, so right now, the electrons are exactly where they want to be at. They're as spread out as they possibly could be, but if I take maybe this end of my fur and I rub it against this end of the balloon, right, that's going to create some friction. That's going to generate the energy necessary to kind of get electrons to go to one side or the other. So then the question is, well, which way do electrons jump? And we have to look at the electron affinity of an object in this case to figure that out. In this case, the balloon, compared to the fur in this instance, has a greater electron affinity, which means it just wants electrons more. So when we rub these objects together, even though electrons want to be spread out, that energy causes electrons to jump over. That added energy causes electrons to jump over to the balloon. And so if that's the case, I'm going to get rid of my neutral circles around here. Right, now notice, though, that since both objects are insulators, that the electrons only jump from that point of contact. Right? All the electrons that weren't in contact with my balloon from the fur, those stay put. And the electrons that did jump over to the balloon, those stay at that point of contact as well. Even though they'd like to spread out, right, get as far away from each other as possible, the insulator, being an insulator, that material doesn't allow those electrons to move. So we've explained what charge the balloon has, but now we got to go to the plastic ring. So I reset the board a little bit, and we can see that that negatively charged balloon from just before is now up here, and I still have the fur, but now I brought the plastic ring into our scenario as well. So the plastic ring is also going to be an insulator, just like all these other objects. It starts off neutral, so same amount of protons to electrons, and one thing you're going to be noticing about the fur is that it's neutral again. Right? So you might be wondering, well, wasn't it just positively charged from the last scenario? It was, but keep in mind that when you grab the fur to go charge that plastic ring, you're grounding the insulator with your body, right? With your hand, you're neutralizing it. So our fur in this case is not going to be positive, it's going to be neutral again. So this is really the same type of scenario that we just saw with the balloon, right? Even though electrons want to be exactly where they're at, that force of friction is going to cause electrons to go from one side to the other. Which side do they go? Well, in this case, if it's ever charging by friction, we're looking at two insulators. We're going to look at electron affinity for that. The plastic ring has the greater electron affinity, so electrons are going to jump over at that point of contact. I'm saying the point of contact's right here. All right, get rid of these neutral circles. So my fur becomes positive, and my plastic ring becomes negative. Remember, since these are both insulators, the charge stays where it is. So the electrons that jumped over, those stay clumped up here. The electrons that left, there's no other electrons in the rest of the material that kind of jump over or anything, so that charge is localized. Okay. So by modeling what's happening with the electrons and everything, we could take a step back and answer the question, why does the balloon cause the plastic ring to levitate? Well, we'll notice that this balloon has a negative charge and the plastic ring has a negative charge. So if I have the balloon underneath that plastic ring, right, that negative charge is going to repel the negative charge. The negative charge of the balloon is going to repel that negative charge of that plastic ring, and that's going to cause them to levitate.